Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilyas bin Hazami, and in this video I will show the demonstration for the linked list. So for the linked list, in this program I need to enter the option 1. Next, there is 3 implementation method that I can choose. So I will choose the option 1 to show the demonstration for the implementation for add first. So the program will need the user to enter the number ID of the customer. So I will add the number ID. Next, the name of the customer, the contact of the customer, and the month for rent, for example 12 month, and the storage unit, for example 10 unit. The program will show that it will performing the add first, and then the linked list before sorted is this is the linked list: ID, name, contact number, month, and storage unit. And performing the insertion sort, because of there is only one element, because of there is only one list in the linked list, so there is nothing to be sorting. Next, I will show the implementation for add last 2. So the ID, name, number telephone, month rent, for example 23 months, and the storage unit is 23. Here the program will show the linked list is performing at last. So for the at last, the new ID is Aiman, so Aiman will be added at the last. So it is true here, Adam and then Aiman. So after the sorting algorithm, so because of ID Aiman has lesser than ID Adam, so ID Aiman here has 1, 2, 3, 4, 5, 6, 7, 8, 9. Meanwhile, ID Adam has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because of ID Aiman is lesser than ID Adam, so it will be sort Aiman and then Adam. Next, I will implement at middle. So for the ID is name, number telephone, rent. For example here, if the storage unit is occupied, the previous storage unit is occupied is 23. So if I enter 23, it will display the storage unit 23 is occupied. So please enter other than 23 and 10. So I will enter 11. So at which index that want to be added? So there is two size. So I want to add at the middle. So I will add at index 1. So the linked list insert, because of previously we have sorting the linked list. So Aiman is first and Adam is second. So that's why Aiman is first, and then ID Ali is at the middle. The last ID is Adam. After the sorting, Aiman is first, and then Ali is second, because Ali here has 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 number less than Adam. Adam has 10 number. And then Aiman is 2023 12, but Ali is 2023 32. That's why Ali is greater than Aiman, and it will display after Aiman. So to show the implement at first is true, I will run again the at first. So option 1 at first, and then ID. This time I will add 10 numbers. 19, 24, 25, 26, 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 12. So name Alia, contact number, month rent is 23 months, storage. If the storage put is 51, the storage is exceed because the data taken for only 50 storage. So if 50, then it will be insert. To see the implementing at first is true, is successful, the name Alia will be at the first. And then for the sorting, because of Aiman and Ali has 9 numbers, 9 digit at their number ID, so that's why Aiman and Ali comes before Alia. Now we will proceed for the remove, deletion. So to delete the customer's detail, we need to enter the number ID. So here, for example, I want to delete the number ID for Aiman because he is at the first linked list. Then it will implement the remove at first. So here it is successful performing remove at first because Aiman is at the first linked list. Next, Ali is at first linked list. Next, to implement the remove at last, I will enter the ID at the last linked list, which is Adam's ID. So it will perform the remove last because this ID is at the last. So there is only Alia and Ali ID. To implement the remove at the middle, I need to add another one so that the size at the linked list is odd number. So at first, Ilyasa ID 2023. This is the biggest ID. And then at the sorting, so Ilyasa will be at the last because his ID is the biggest value among the others. So to perform the remove at the middle, which is Alia, I will take his ID. I will take Alia ID and then performing remove at index 1. Index 1 is at the middle. So the customer's details in the linked list only have Ali and Ilyasa's details. If the ID does not exist, for example, I will put a random ID. The program will tell that the customer's ID is not in the linked list. So it will not make any deletion. That's all from me for the demonstration of the linked list.
So now I will show how the system works. So first, there will be a main menu appear for the mini project program. So there's a 7 option. So what we'll do is we will do the option number 1, which is to sign up for rent a storage unit. So I will enter my choice, which is number 1, and then another menu appear, which is to select method to insert the data into linked list and 3 simultaneously. I forget to tell is option 1. So this is the coding for option 1. So when we put number 1, so the next menu will be appear here, and then from here the menu is to select method to insert the data into linked list and 3 simultaneously. So we will choose option 1 where we want to add first the new data. So here we can sign up for new customer using add first. So we will put the number ID, and then we will put the name, then the contact number, and then month for rent, and then the storage unit. So now it perform the insert tree, where here it use the tree.insert, where it already insert the data that we enter, the number unit, the name, the ID number, contact number, and month for rent. So for here tree.inOrder, this is the output where it shows that it in order sorted, and the number ID, which is we put just now, and then the name, contact number, month, and storage unit. Followed by next is 3 pre-order, which is here the pre-order. It is the same 201 as a root, because this is the first data that we insert, and the same. And then next is a post order, 3.post order, also the same data. And then the last one is it will show the number of nodes or the number of data or customer that we have. So right now we have 1. So this is the output for this coding. So next we will perform the second option. So this is the second option. So we will do the second option, which is we want to delete the customer data. So number ID want to delete, we have only this one ID, which is 201. So we will put 201, and then here same as previous one, but the output is different because we delete the data. So it still do the performing delete, it do the performing delete 3. And then for the 3 in order, 3 period order, and 3 post order, the output will be different, where they don't have any data to display because we already delete the data. So next we want to do the option 3, which is we want to search customer storage unit number. But before that we need to put back the customer data, customer ID, because right now we don't have any data, so we cannot search any customer. So we will put a new one. So but first we will choose number 3, which is we want to search customer, and then there's no customer, or if there's no customer, then we choose to search the customer. The output will be like this, where there is no data to display because there is no customer ID. And then here it asks us to put a customer ID. So let's say we put 201, but we already delete 201, so we try to search it back. So it shows that customer ID 201 in the tree. No, it is because we already delete this data. So we will do it back, but before that we need to sign up a new one. So first we will sign up a new data, then same at first, then we put new ID 202, then we put name of Aiman, and then contact number and then month for rent, and then storage unit. So now it's performed the insert tree like the previous one, like we discussed just now. So now we already have a new customer, new data in our system. So right here we can perform this option 3, where we can choose, we can search customer storage unit number. But to make it looks better, we will add one more data, one more customer. So we choose option 1, sign up, and then at first we put new number ID, then month for rent, and then storage unit. So right now it performed the insert 3 in option 1 just now. So right now it display the 3.in order, where it display this all the number ID, all the data that we have. So here also the same, pre-order and then post-order also display the same, but here the difference is the sequence, where the now for pre-order the root is 202, but for the post-order is 203. And then right now with the total of nodes that we have is 2. So after that we can perform this option 3. So I'll show the option 3. So choose 3. So this is the list that we have. So we can choose to search what data that we want. So I decide to choose 203. There we put the customer's ID that we want to search. Then first it will state first whether the customer ID is in the tree or not. So it is yes, there is in the tree. And then after that it will show the path of the route as we have this path equals to tree.path. So from here, after we have declared whether the customer in the tree or not, so it will show the path from the root to the 203, the number ID that we want. So from here, the 202 is the root. So next followed by the number ID that we want. So it show from the root until the number ID that we want. So next option number 5, which is evolve 3. So after all of this data that we put, we will save all of this into the JSON file. So we will choose number 5. So right here, up here is a linked list. It write the linked list of the data, but and then down here it write the write.3, which is this option number 5. Write 3. So right here it shows that it started writing 3 for the customer ID, followed by done writing JSON data into JSON file. So followed by customer name, customer contact, customer month, customer storage unit. So right now we already save the data, all the customer data into this JSON file. Now we can read the data. So we choose option number 6. So here the tree, it shows the data that we have been saved in the JSON file. So we save and then we put it back here in the system by read the file. So this is the output. Number ID 202, name Aiman, contact number 09556471, month for 7, unit number 2, followed by Lukman 203. So I think that's all about how the system works. Involve 3, where I already tell about how the tree works in the system. So I think that's it from me. Thank you.
Hello, good morning to Dr. Roslina. My name is Muhammad Ramin bin Muhammad Kamel, and today I am going to present the software, the program that has been successfully compiled for task 3. So let's run the program first. Okay, this is the main interface that will be shown right after the program is started. And since my task is graph, which is task number 3, it is at option number 4. So let's choose option number 4. And first thing first, it will show all of the vertices that has been created. And the next option was choose selection for graph, which is there are 4 and 5 options. So first we run option number 1, which is BFS. So let's run. First thing, it will ask to enter root. So let's enter, or before that, let's see this graph in a visual form. So this is the graph in visual form. Let's put side by side. Then first it asks us to choose the root to perform the BFS. So let's choose node number 1, which is Kuala Lumpur, as the root. Okay. Then the program will show the output result, the answer in BFS order. 7 vertices are found in this BFS order, which this is the order, which is Kuala Lumpur, Shah Alam, Kapar, Subanjaya, Puncak Alam, Bangi, and Putrajaya, when Kuala Lumpur is chosen as the root. So let's check whether this program is correct or not. So let's see at this one. So as we know, breadth first search is it will perform where it will perform a visit each node on a given level by level. First node visited on a given level should be first node to which we return. So from this graph, you can see Kuala Lumpur is on the first level 0. Then we move to Shah Alam. There are 3 options for Kuala Lumpur, but we choose the alphabetical order, which is 0 is the minimum, so we choose 0 first. So the first is Shah Alam, and then there are 2 options left, which is Kapar and Subanjaya. We choose Kapar, and that's the second option since 2 is smaller than 6, and then Subanjaya as the third. And then it has no more vertex, so it will move to Shah Alam, and the another level has 3 options. So this time we will choose Puncak Alam as number 4 because of the ascending order, and then number 4 and number 5 is for Bangi, and then Putrajaya. So this is the BFS order. Let's see, is it same? Kuala Lumpur, Shah Alam, Kapar, Kuala Lumpur. Oh, sorry, wrong answer. Kuala Lumpur. So let's ignore this one. Let's see. Kuala Lumpur, Shah Alam, Kapar, Subanjaya. Kuala Lumpur, Shah Alam, Kapar, Subanjaya. Puncak Alam, Bangi, Putrajaya. Puncak Alam, Bangi, Putrajaya. Same. So, and then we can see this is the parent for each vertex. Parent of Shah Alam. Parent of Shah Alam is Kuala Lumpur. Yes, Kuala Lumpur. Parent for Kapar is also Kuala Lumpur. Parent for Subanjaya is also Kuala Lumpur. So the parent for Puncak Alam, Bangi, and Putrajaya is Shah Alam. So let's see, Puncak Alam, Bangi, and Putrajaya is Shah Alam. So the program is correct. So let's see from the other view. So we choose the other root, BFS again, and this time we choose kappa as the root. So let's see. This time we choose kappa as the root. So this is the order. Kappa, Shah Alam, Kuala Lumpur, Puncak Alam, Banyu, Putrajaya, Suruhanjaya. So let's perform BFS on this. So kappa will go to Shah Alam, and there are the other two remaining on the level. So it will go to Kuala Lumpur since one is less than 3, and then this one. So there are no vertex found in this level, so move to the another level. Since 4 is the smallest value on this level, so it will choose 4 and then 5 and then 6. So this is the BFS order when kappa is chosen as the root. It is same with the program. Kappa, Shah Alam, Kuala Lumpur, Puncak Alam, Bangi, Putrajaya, Suruhanjaya. And this is the parent for each vertices, which is the parent for Suruhanjaya, Putrajaya, Bangi is Shah Alam, and the other three for Kuala Lumpur, Shah Alam and Puncak Alam is kappa. So that is for the DFS. So let's choose the second option, which is DFS. So first thing first, we should choose the root. So this time we choose Kuala Lumpur again as the root, and the DFS order for this is Kuala Lumpur, Shah Alam, kappa, Puncak Alam, Bangi, Putrajaya, Suruhanjaya. So let's proceed on how to perform the DFS. So as we know, DFS in DFS, the rule is visit the adjacent the unvisited vertex and then push it in a stack. If no adjacent is found, pop up the vertex from the stack which do not have the adjacent vertices. So let's perform the DFS algorithm. So this one, Kuala Lumpur as a root. First, it will go to Shah Alam since this is the less value, and then at this one we can see there are 1, 2, 3, 4, 5 options. So it will choose the minimum value, which is 2, and then it will not go to 1 since 1 is visited, so 2 will go to 3, 3 will go to 4, 4 will go to 5, and 5 go to 6. So this is the DFS when Kuala Lumpur is chosen as the root. Does it same? Yes, Kuala Lumpur, Shah Alam, kappa, Puncak Alam, Bangi, Putrajaya, Suruhanjaya. And then the same process, which is they show the parent for each vertex. Which is we can see Suruhanjaya, Putrajaya is the parent for Suruhanjaya. Yes, we can see it is same with the theoretical answer. Now we perform again by using the different root. So now we choose kappa as the new root. So this is the DFS order when kappa is chosen as root. So let's look. Imagine kappa is chosen. So there are 1, 2, 3 options to choose, but it will go to Shah Alam since node 0 is the smaller, and at 0 there are 5 options. It will go to Kuala Lumpur since number 1 is smaller than the other. It will not go to 2 because it is the visited node, so it will go to 6. 0 is visited node, so go to 5, go to 4, and go to 3. So this is DFS order, which is same as the output from the program. This is the parent node for each vertex found in this DFS order. You can see Shah Alam is parent for kappa. Shah Alam is parent of kappa. So now that's is for BFS and DFS. The other program is shortest path for the location. For this option, Dijkstra algorithm is used to get the shortest path for the location. So let's choose option number 3 and pick one no, a route location as a route. So we choose Alam. Okay, this one, it will show all of the minimum shortest path from Alam to anywhere, to any vertices. Okay, so let's see, is the answer is same with the theory. So this is the table to determine the shortest path when Alam not 0 is chosen as the route. So we can see here 0 to 1, 0 to 1 is Shah Alam to Kuala Lumpur. So let's look. Shah Alam is 0. Shah Alam to Kuala Lumpur is 25.1. See 25.1. And then 0 to 2 is 0 to Kappa. Shah Alam to Kappa is 25.7. Is same. Shah Alam to Puncak Alam 32.6. 0 to 3. Shah Alam to Bangi 46.6. Shah Alam to Putrajaya 40.4 and Shah Alam to Subanjaya 12.1. Can look at this. It is the program same as the theoretical answer. So this one we just choose we want to go anywhere we want to go. So let's say from Shah Alam we want to go to Kappa. Yeah, 25.7 same as this one. Okay, we make another possibility. So we choose again for minimum and shortest path. Now we choose one, which is Kuala Lumpur. So we choose Kuala Lumpur as the route. So let's see. This is the table used in Dijkstra algorithm to determine the shortest path from Kuala Lumpur to every node available in this graph. So we can see the shortest path from Kuala Lumpur to Shah Alam is 25.1, which is from node 1 to 0. So node 1 to 2 is from Kuala Lumpur to Kappa, 50.8, and node 1 to 3 is 57.7. 1 to 3 Puncak Alam, same, and Kuala Lumpur to, okay, I got to explain this one because there are a multiple route they can choose. So this program show which route the shortest route they choose. So this one, let's pick this one, Kuala Lumpur to Puncak Alam. So from Kuala Lumpur to Puncak Alam, it will use the route Kuala Lumpur, Shah Alam, Puncak Alam, which means the route will go to from 1 to 0 to 3 rather than 1 to 2 and 3 or 1 to 0 to 2 to 3. It will choose this route, the shortest route. So the combination from these two weightage will give 57.7. And from Kuala Lumpur to Bangi, which is not 1 to 4, it will choose the path from Kuala Lumpur, Subanjaya, Kuala Lumpur, Subanjaya, Putrajaya, and then Bangi. So this 1 to 6 to 5 to 4 is the shortest path, which has a total cost of 50.7, same as the theory, 50.7. So the last one, 1 to 6. 1 to 6 is the adjacent, so just one node and it's same 31.5 same. So we choose to go to Subang Jaya. Okay, 31.5. So last but not least is the minimum spanning tree. So to perform the minimum spanning tree, the same process also had to be chosen by user, which is which route they want to use. So let's choose Puncak Alam as the route. So Prim algorithm use route is when we use Prim algorithm, we should choose the route. So this time we perform the Prim's algorithm. So the route is Puncak Alam. So let's perform the Prim algorithm. So from Puncak Alam, it has three options. Of course, it will choose kappa, which has the most minimum cost, and then at node number 2, it will choose node number 0 because from the other, this is the most minimum cost, and then move to 6 and move to 1. As long as the graph does not make a loop, let's say this one, if this one have the most minimum cost, it will not choose this one because it will make a loop. So that's why it will choose this and this. And then from the balance, we choose this one since it have, so see 29.5 is larger than 25.1. But why we do not choose this one? Because it will make a loop. So we choose, instead of choosing this one, we choose this one. And lastly, this is the last pass. So this is the minimum spanning tree by using Prim algorithm. So let's look at the answer at the program. The total cost is 122.5, same as the combination of this cost is same as 122.5, which is same. And let's see the root, is it correct? Yes, Kappa Shah Alam is one of the edges. So see Kappa Shah Alam, this one. Subang Jaya Kuala Lumpur, Subang Jaya Kuala Lumpur, this one. Okay, let's get rid this one, get rid this one. Puncak Alam Kappa, Puncak Alam Kappa, this one. Putrajaya Bani, this one also. Subang Jaya Putrajaya, and last one Shah Alam Subang Jaya. So all of the edges are correct. So let's see if we perform the cross-cut algorithm. By using the cross-cut, we perform from the minimum weightage to the smaller weightage to the higher weightage. So we choose from the lower value as long as it does not performing a loop. So 0 to 6 we can choose, 4 to 5 we choose, 2 to 3 we choose, 0 to 1, okay, 0 to 1 we can choose because it will perform a loop. So ignore this one. 0 to 2 we can choose, 5 to 6 we can choose, and that's all. It is same as the Prim algorithm. So that's all. Task 3, the program for the task 3. The last option is back to main menu, so we choose number 5. yeah, it will back to the main menu option. So that's all. Thank you.